Good morning. So my name is Takuka Benda, and today I'll be lecturing on advanced backend development. And we'll be looking at building scalable, efficient, and modern server-side applications, the tools that are needed. And so we look at the introduction. We look at the introduction. Um, okay. So first, what is backend? So backend is the brain of the application. It's a part that the user don't see. Okay. But in the same time, this is a part that the system uh, cannot live without. So advanced backend development is not just about writing code, it's about designing systems that are robust, scalable, and maintainable. Yeah, that's where system architecture or system design comes in at the backend level. So in this presentation, we'll cover the following: to choosing the right server-side language, navigating the complex world of databases, building modern interoperable systems with RESTful APIs and microservices. Server-side programming, choosing your language. What language do you use for server-side programming? We'll look at three languages: Node.js, JavaScript, Python, and Ruby. These are the three languages that we'll discuss for this presentation. Now, the language you choose dictates the ecosystem of tools, libraries, and framework you will use. Firstly, we look at Node.js, the pros of Node.js. So Node.js is asynchronous, non-blocking IO module, which is very great for real-time applications and APIs. Node.js is fast with development, and it has a very huge community support. It has the NPM, a very robust um, tools for um, different tools to use in Node.js. And then some of the cons of Node.js, we have Node.js not being ideal for CPU intensive tasks, or tasks that require very huge CPU usage, as it can be complex, to manage the callbacks, right? Callbacks function through promises and async or with help. So some of the use cases of Node.js is good to use for real-time chat applications, and that's why most of the social media applications use Node.js. And for streaming services also, so streaming services, most of the streaming services, real-time chat and single-page application, they use Node.js. So for Python is a very reliable, readable syntax. Python has a very huge library ecosystem. Um, for example, for the web, we use Django, Flask. These are all libraries um, of Python, frameworks of Python that can be used for web. So also excellent for data science, for machine learning and scripting, for AR. Python is excellent for that. Some of the cons of Python is that so there's a slower compile time, okay? And then concurrency also is an issue for Python because of um, the GIL, that's the global interpreter lock. So the use cases of Python for data analysis, for machine learning, for web applications. So most of the AI and machine learning applications that are being built currently, they use Python. So in some instances, some use Java, but Python is one of the key for systems that are artificial intelligence systems. So Ruby has an elegant tax syntax, okay, and that's why it's called developer happiness. Philosophy is a powerful framework in Ruby on Rails, because basically Ruby is for rapid development. That is, if you want to build a website within a very short time frame, Ruby is your goal. The con of Ruby is that Ruby has slow performance than other languages like that Python or Node.js. Some of the use cases of Ruby is that Ruby has write-paid prototype for e-commerce and content management system, CSM. So there are other languages for server-side programming. For instance, you have Go, you have Java, PHP. So ultimately, the best language depends on the project requirement and the need of the project owner or the users. We look at deep dive into databases. So databases are the persistent layer of an application. So the choice of database technology is very important when it comes to the architecture design or decision. So when it comes to database, we're looking at three different types. We look at SQL, NoSQL, and GraphQL. So SQL has to do with relational, as relational. So we firstly, how does it work? Well, SQL is very structured. SQL uses table-like with very fixed schema, and there's an ACID property. Those are the key features of SQL. So some example of SQL include PostgreSQL, MySQL, SQL Server. Those are the popular ones. Yeah. So when to use? Well, when you need straight data integrity, when you want relationships and among tables, or you want a well-defined business rule, then you go for SQL because relational. It's a very popular database type, okay, that has been around for quite a time now, and up to now it's still popular. So the NoSQL, which is no relational, is very flexible and not structured as the relational. So it has a very flexible schema, right? So NoSQL is document, key valued, or even graph, right? That's how it is. So for NoSQL, prioritize scalability and flexibility. That's NoSQL. So examples of SQL databases is MongoDB, Redis, Neo4j. These are all examples of popular Node.js, NoSQL platforms. So we use NoSQL when we want large amounts of unstructured data, one high availability, and one horizontal scaling. The third type of database is GraphQL. So GraphQL works it's a query language for API. And it's not a database. Actually, it's allow clients to request exactly what the data they need. Okay. So the key advantages of GraphQL is that GraphQL is able to solve overfetching and underfetching issues with respect to REST APIs. And some of the use cases of GraphQL when it comes to mobile applications, it's used. GraphQL is also used when it comes to clients that have need of verified data needs or complex UI. So that's about these databases. Look at the RESTful APIs, so which is the standards for communication. So the first we'll talk about the choose your language, the second is database, and now it's the RESTful APIs, which is the standard for communication. So as a set of rules for building web services, that's what APIs are. It's an architecture actually. And the principle of RESTful API, so it's stateless. Each request is self-contained. RESTful API is resource-based, as everything is a resource, okay, identified by the URL. And then it has a standard HTTP method. For example, you have the get, the post delete for those actions. For example, you use get where you want to get a list of users, post, we want to post something to the database, let's create a new user, we want to delete. So all of these HTTP methods, they are used for specific actions. So, well, APIs is the lingua franca of the web. And basically it's for having different systems to to communicate, allowing system to communicate, exchange data. That's about RESTful APIs. So we look at microservices. Microservices came to decompose the monolith architecture of software development that legacy systems, were used to build. So microservices is an architecture star where the large application is broken down into a suite of small independent services. Now, the monolith, as I said earlier, the monolith is a single large code base. All the functionality is in one application. That's monolith. But then the microservices, there are many small and independent services, and each service does one thing well. Okay. For example, a user service, auto service, and so forth. There are so many different services that are independent. Okay. So whenever there's a problem, we can just go directly to a specific service. That's microservices. And we have the advantage and disadvantages. So when it comes to scalability, we're able to scale individual service as needed. That's one of the advantages of microservices. And then we also look at the autonomy of the team. So the team can work and deploy independently on different services, and then the technology can be diverse also, right? Look at the disadvantages. It's complex. Actually, it's very complex because when it comes to distributed systems, I mean, it's hard to manage. And then the operation overhead so requires robust tools for monitoring, for logging and discovery. So the conclusions and key takeaways. So we've explored the three pillars of advanced backend development. And so the key takeaway from this presentation is that there's no single best language for database. Okay, there's no single best language or database. So the right choice is always a function of the project's need. That is what the project's requirements are. So RESTful APIs provide a simple and powerful way for systems to communicate. That's RESTful APIs. Microservices offer a powerful module for building large, resilient applications, but they come with added complexity. So the best backend developers are not just coders, they are architects who can design and build systems that are not only functional, but scalable also. And that's very correct because the central, cool, and important, significant thing about backend development is system design. All right, it's architecting system that will not fail but succeed. It's designing system that is able to perform under any given load, okay? Optimal performance and so forth. So thank you again for listening to this presentation.